Check. Okay, checking the mic. Checkity check. Okay, looks like we are good. So I kind of figured out the metering. Let me show you what it looks like. I did something interesting. What's up, B samples? Did you ever did you want me to do that that JMap example for you that you sent me in text on Tuesday? So also what I'm doing is whenever the signal goes above 0 and peaks, I'm making the shadow and the center of the dial red. So check this out. I'm gonna turn down the volume of the track a lot so that see how it flashes red whenever it goes above 0. Okay, good. All right. So I think this is pretty much the end of the gain plugin. There's not really much more I can think of to do for it. We've got this little red metering for whenever the signal is too hot. So let's put that back down, and now it's normal. And that's pretty much it. It's pretty much ready to go. Let's check. Did I do the saving of the plugin state? I don't remember. Oh, let me get rid of this. Okay. And let's see. Thanks. Although, hold up, what's this? Why is there a copy of this? Level dB less than level gain. Okay, apparently that's what I did, so I'm gonna leave it like that, and then you can get an example. Okay, and then let's do this. We're not doing any of the saving of the state, so it's pretty simple. We just have to save the tree to a memory stream, and then on set state we're gonna get that tree from the memory stream. So I can never remember how to do this without looking at one of my other examples, because I always just copy and paste it. So let's see. We can go into JUCE plugins. No. I'm gonna go into mine. Restore DSP demos, something that I know. Okay, my template project. Yeah, that'll be good. And here we are. Okay, so get state and set state. Get state gets called whenever the host saves its state. So like if you're in Logic and you press save, hold up, Zoe is trying to go under the microphone. So if you're in Logic and you hit save, get state information will be called, and then whenever you load up that project again and the plugin loads up, set state will be called. So So here's what we can do for get state. We don't need that. So easy. So we make a memory output stream, and let's see, I got the wrong name. It's probably just called tree state, right? How about you pick? We're gonna do another plugin from the JUCE DSP modules. So timer callback with image and buttons. What do you want to do with the timer specifically? So anyway, memory output stream, we're gonna call it stream, and we're gonna give it destination data, and then we're gonna write the tree state to that stream, and then we just need to pick it back up in set state, which is pretty easy. There's a couple extra things in here that we don't need, like that and this. So yeah, we're gonna create a tree, and we're gonna set it equal to the data coming in, and then if that is valid, we're gonna take our original tree state and set it equal to this kind of local temporary tree. So it's pretty simple, and that's it. Yeah, so either I'm not sure what you want to do with the timer, but I also want to do we're gonna make another plugin example that's going to be from the JUCE DSP module, so we can do I don't know what would be a good second example after gain, the cheat demo that pops up, image with the button to it, different version for your gain plugin you made, or I can come up with another idea. The cheat demo that pops up. Oh, I had never figured out how to get the image to pop up with the dialogue. Let me commit that. Okay, yeah, sure, let's do compressor. That's what I was thinking too. So let's go to JUCE, delay on the internet. Yeah, I was gonna do delay a little later because the delay naturally goes into like chorus and other modulation effects. Yeah, so let's go into DSP. We've got, is there anything better than compressor for right now? So here's compressor. We could do a filter. Limiter, reverb, wave shaper. Wave shaper might be a good one. Yeah, let's do compressor. Yeah, let's do compressor. Let's do the limiter after the compressor because the limiter actually uses two compressors inside of it. So let's see. We're gonna have to make another folder, so we're gonna go into that JUCE repo. Where's it at? JUCE plugins. Good. Okay. Demo plugins. Okay. And simple. DSP. Okay. So let's make a new one. New project. All right. So plugin basic. Compressor basic. We're definitely going to need the DSP module. Let's see, compressor basic. Yep. That's going to go in simple GUI. Nope, simple DSP. Yep. And there. And let's just change the name real quick. Audio Plugin Coders Guild. Good enough. Okay. Let's go ahead and hit save and open an IDE. We can get rid of the other game project. Okay. On standalone. And first things first, so this one's gonna be simple, so no GUI, so we're gonna use the generic audio processor editor. This, okay, and then let's build it and make sure that it just comes up with a little blank rectangle. It's gonna take forever. All right, here we go. Oh, it's sure taking its sweet time. There we go. There we go. Okay, good. All right, cool. So let's get rid of all this nonsense right here. And let's start building everything we need. So what do we need? We need a value tree, definitely. JUCE is going to hold our parameters. Call it tree state. We also need our parameter layout and our parameter changed method. So here's the parameter layout definition, and then here's parameter changed. And then to use parameter changed in listeners, we need to inherit from audio processor value tree state listener. So I think that's right here. Public. Let's see if it's gonna pop up. Xcode. Oh. Oh wait, I think I did this last time. There's this new macro thing. Do I put it here? Yeah, there we go. All right. I'm not gonna use this, so I'm just gonna get rid of it. I don't even know what that is, so. All right, so we need to construct the tree state. Okay, there we go. Processor to connect to this, not using an undo manager. Just call it parameters, and then we need to call create layout. Cool. And then these two methods that we defined, we need to actually implement them. Oh, let me also, before I forget, make the code bigger so that it's easier to see on video for y'all. So these two methods right here we need to implement. So let's go here. So here is parameter layout, and by default it puts in one parameter. We need to make sure we carry over the class name. compressor basic like that. And then let's see, we also need parameter changed. So we need the class name. What are our parameters? Let's just take one. All right, threshold. Yeah, the zoom is much better. So I'm just gonna make one to make sure that this works. So p thresh, we're gonna call it thresh for the ID, and then thresh for the name with a capital T. And thresh probably, I don't know, -60 to, what does the SSL bus compressor go up to, 10 or 15? Let's do 10. And then 0 by default, that seems good. P thresh, okay. And we need to lastly create a listener for each one. So we're gonna say tree state, add parameter listener, and it's gonna be for thresh, and it's gonna be pointing at this. And then in the destructor, we're gonna remove it. Remove parameter listener. Thresh. Oops. This, and now anytime the listener hears a change for this ID, parameter changed will be called. We'll get that ID here, and we can get the value of the slider or whatever it is. So for right now, let's debug that parameter. So it would be tree state, get raw parameter value is going to be thresh, and then it's atomic, so we call load, and that gives us the float. So this should be called if we move the thresh knob, and since we're using a generic audio processor editor, it should just pop up the slider. I mean, perfect. Okay. And then, yeah, look at the console. We're getting our values, so that's good. All right. So let's do this for all of the parameters. So we've got how many? Thresh. Let's also do an input and an output variable. Let's do that after though. So ratio, attack, and release. Very simple. Okay. Okay. So ratio. Attack and release. Okay. Okay, and then let's put them all in here. And this, I'm actually going to change the way I do this eventually, but it's fine. Nothing wrong with it. Okay, then let's add the listener for each one. And then we can do the same thing here. We can check to see that each one works. So ratio, attack, and release, and we should be good. Okay, Okay, so let me expand the console so it's easier to see. All right. So we see all of them, but only thresh is changing. Put that back at 0. Okay. Oh, you know what? We're gonna have to do this. It's gonna be hard to tell which is which. So let's add a string in there. That ought to help. Yeah, okay, thresh is moving. Now ratio is moving. Attack, yep. And release. Okay, good. So our parameters are moving. Oh, and let's make it input and output. Yeah, that's what the output is, makeup. We'll do an auto makeup on the advanced one. This is the basic one, so it's just the DSP module. So, output. Okay. Input and output. Input and output. Right, and then do this here. Input. Okay, let's make sure those work. All right. Input, yep. Thresh, yep. Ratio, yep. Attack. Release. Output. Okay, cool. So we need to actually change our values. So I guess the input can be -60 to 24. Same for the output. Thresh is good. Ratio needs to be between 1 and 20. And default at 1. And attack and release. Let's open up logic and see what logic's attack and release are for the default compressor. All right, I'm just gonna pull up logic compressor. Sure, let's look at the VCA. From 0 to 200, but 50 is in the middle. Okay. And the release is from 5 to 5,000 with about 150 in the middle, 160. 5 to, did I say 5,000? Yeah, okay. And so we need to skew these values a bit So I kind of forgot. Let's look at normalizable range and see if there's an easier way to make a midpoint, or if that's just on the slider. Normalizable range, float, sure. Okay, range start, end, interval value, skew factor. Convert. Given a value which is between the start and end point, this sets the skew such that convert from 0 to 1 will return this value. Okay, I'm gonna try that. All right, so 5 to 5,000. So we're gonna do a JUCE normalizable range float from 5,000. It moves by 1, and then I can call set skew for center, which is 160. I'll do a double. And what doesn't it like? No matching function call to make unique. Okay, let me take the set skew out. Okay, so yeah, it works without the set skew thing in there. Which means, what's up, JoeBot? I wonder if I can just make, yeah. JUCE normalizable range float release range is equal to this. Okay, first of all, does that work? Am I doing that correctly? Okay, and then what happens if I do release range dot set skew for center, which is 160.0f, and then what happens if I put this here? Looks like that might work. Okay, release, that's 5. Here's 160, which is about the center. And then, yep, look at that. The skew seems correct. Okay, very good. Okay, awesome. So now we can do the same thing for attack. Never done that before. That's pretty useful. Attack, which is 0 to 200. And attack range, the center was 50. And then we will put attack range right here. Very good. Look at that. All right. Awesome. So I actually want to have them start in the center. Let's do that and that. And that should be good. Okay. Now we are going to make our actual gain module, compressor module. Okay, so very simple. JUCE, it's in the DSP namespace. and it is called compressor. It takes in a template type, so you can pass it float or double. Pass it float, and this will be, did I spell that right? Yeah, I did. Compressor module. Okay, so the most important things you need to do for one of the DSP modules is you always need to prepare it by passing it a process spec, and then you need to call process in the process block. So here is the process spec. So we create a process spec and call it spec, and then we set the block size, sample rate, and num channels. And the reason we give this to the DSP module is because the DSP module needs all this information, but especially the sample rate. That's really important because a lot of the parameters inside of these DSP modules use what's it called? Smooth value, and smooth value relies on the sample rate to work correctly. That's just one example. I'm sure there's other things, but we can just call module and prepare and pass it the spec that we just made. Very simple. And I actually want to make a method called update variables. Do that here, void update, or I'll say parameters. I'm gonna put that right under parameter change, and this is gonna look a little weird, but it's helpful because it allows you to not have to copy and paste code 2 or 3 times. So this is gonna be update parameters, and what we'll do is we'll call each of these set threshold, ratio, attack, release. So we'll say compressor module dot set. Oh, let's do them in order. Threshold, which is this. And we keep going down the line. Set ratio. There it is. And then, oh. Attack. And release. So here's release. And what we'll do is we'll call this update parameters in parameter changed because they need to be updated. And the reason I put this into a method is because I also want to call this in prepare to play, so that whenever you open up the plugin for the first time or after you save, it will initialize the parameters and make sure that they're correct before audio starts, which is helpful. So it just looks cleaner than having to copy and paste, you know, these 4 lines into the prepare method. And we also need 2 gain modules. So let's do this. We have an input and an output. So we need some gain modules. Input module, and then we'll make a second one called output module. Cool. That's that. Let's prepare them. Input module dot prepare spec, just like the compressor. Output module dot prepare spec. Okay. And we need to add the input and output. Oh, also, gain module has one more thing that I'd like to set. So input module dot set ramp duration in seconds. This is basically connected to the smooth parameter. So this sets how long it takes a parameter to smooth from an initial value to what you moved it to. So if this is no duration, so like 0, you'll hear like popping and clicking. So you need to smooth it out. And usually just something like a 0.02, 20 milliseconds is pretty good. So let's do that for output as well. Okay. And we need to update the actual gain values. So let's go here and we'll say input module dot set. I like using gain decibels because usually that's what your slider is going to be anyway. So let's put input in there. And then we will do the same thing for output. So like that ought to be good. Now we can get rid of these. Okay. So now our parameters are being updated. So now we just oh, what's up, Mr. Tummy? Now we just need to call process. Okay, very cool. Let's see here. So we'll go into the process block and we'll create an audio block. DSP audio block float. We'll call it block, and we'll set it equal to the stuff that's in the buffer. And then we just need to call process on each of the modules. So we'll say input module dot process, and the way you process this is if you're using a block like this, it's pretty easy. You just pass it a processing context. That's also in DSP. So it looks like this: DSP process context replacing, and we give it the block that we want. In this case, we only have one. So yeah, we just take that. We do that for the input compressor and the output. And that's it. Oh, let's do our get state and set state real quick. All right, I'm just gonna pull it from gain advanced, which we just came from. All right, and that's it. We're ready. Let's build AU. I don't think we built it AU yet, so it's going to take a minute or so. But this will be ready to test in Logic. Hopefully it shows up. Oh, that was pretty quick. Oh, Logic is open though. Alright, I'm going to hit build again just in case, because sometimes it won't actually update if you build while the DAW is active. Alright, so we don't need gain advanced on here. We turn the music off. Okay. So that's good right there. Wait a minute. We're in mono. There we go. Alright. Alright, cool. So let's find that compressor. Audio plugin, Coders Guild. Oh, good. It's not there. Okay. So let's shut that down. I'm just going to move it from one library to the other. So I'm going to go to builds, build, debug. So show original, and here it is. That, and we're just going to go to the regular library folder, which, oh, well, I forgot to open a second window. There we go. All right, now I'm going to do it. Go to folder, regular library, which is that one. This is the one where normal plugin manufacturers will put their plugin. So here we go, compressor basic. Boom. Sometimes you have to open Logic 2 or 3 times, but it'll eventually show up. Oh, I think it's actually scanning right there. All right. There it is, compressor. All right, here we go. So let's leave everything default. Thresh is 0, ratio is 1, so nothing should be happening. All right, let's pull the ratio up really high and then start pulling the thresh down. Sounds like a compressor. Pretty heavy sounding. Let's pull the ratio down. Why do they not hold numbers? Oh well. Okay, so there we go, very compressed. Now if I make the release very long, it should sound like it's not keeping up. Yeah. Okay, so it looks like our like skew scaling is working pretty good, because that sounded like a pretty smooth change of release. So let's keep that low. Let's do the same thing with attack. So attack all the way to the left should be, yeah, very splatty sounding, and then should get heavier sounding as we slow it down. Yeah. Pull this ratio back up. And if I pull the input up, it should be similar to pulling the threshold down, because we're getting more signal. Yeah, it doesn't really sound compressed right now. And then if you pull the input up, it starts to compress, and then we can pull the output down, which is basically a makeup. Cool, and then let me make sure that saving works. So let's pull the ratio up to a random spot, and let's pull the attack and release. Yeah, that sounds real weird. All right, let's see here. All right, yep, everything's saved. That's pretty much it. Compressor is done. The basic version is done. All right. And when the ratio is 1, nothing happens, obviously. Okay, cool. Compressor is done. That's pretty much it. There's not really anything else that we need to add to that. Let's see. I guess I could leave some comments. We already have save and recall. Okay. And yeah. Okay. That. Pretty good. Okay, I guess that's it. So let's see, added basic compressor example. Done. Okay, so the next step, I guess, is to make an advanced version. Got about an hour left. I don't think we can really make it in time. Let's see, could we maybe do a different one? Maybe the wave shaper. DSP, let's go back. Wave shaper. Function to use. I kind of forgot how to do this. Flow type function. Oh yeah, you would pass it like tan or something like that. It's weird how they don't have examples. I doubt there's an example in the module itself. So DSP, let's say widget, wave shaper. Function to use. Where is function to use? The other good thing is that you could go into JUCE. Modules. Oh, not modules. JUCE right here. So you can go into examples, DSP, wave shaper. So I just want to try to remember how to pass. Oh, okay, yeah, okay. So you make one, call it shaper, and then, yeah, you just pass. Okay, you just pass which function you want to use. Okay, we could probably do that. So let's go here. I'm going to leave compressor open. New project, basic plugin, shaper. Basic, right? Wave shaper basic. Okay. And JUCE module, DSP modules. This is gonna be DSP. Yep. Audio plugin. Gosh. Coders Guild. Okay. So I'm going to build this once, or I guess I'm going to get the generic GUI going and then build it. Generic audio processor editor, that should be good. Let me just hit build. Get that initial build done, and then, oh, thanks, JoeBot. If y'all aren't in the Discord, go join it. You can ask me questions whenever. I'm on my computer all day long, so feel free to send me messages, show me what you're working on, or ask for help. Okay, there we go. Cool, it built. So let's speed run this one again. All right, first thing, we need a tree state. While this is up, I'm going to copy this so that I can do the inheritance right here. So public listener. Yep. And we need our parameter layout and changed. Here's the layout. Here's changed. We need to construct the tree state. Tree state. One Xcode. State. There we go. This, no undo manager. I just always call this parameters. And then we have create layout already. Cool. And we need to implement those two methods. So here's the layout. And here is parameter changed. We need our actual class name in these. Here and here. I think we're just gonna have an input and an output because the wave shaper doesn't have any getters or setters, so it's just you push signal into it and it gets distorted. So we just really need two, an input and an output. So input and output. Here. Oops. Input, actually, lowercase input and uppercase. And I think this actually works. -24 to 24, I think actually works pretty well. Because sometimes it's useful to be able to drive less input into the whatever you're putting input into. So if I remember correctly, we definitely need a gain module. Let's see. Gain, float. Oh, we need two actually. One for input and one for output. And then we need the actual wave shaper. So let's see here. DSP. See if I do this right. I'm gonna let it autocomplete for me so that. Okay, there we go. Wave shaper, float, distortion, module, and then if I remember correctly, we do that, and then the function. So let's do fast math approximation so that it's a little more efficient. JUCE. No. Is it in DSP? Fast math. Yeah, okay, and then I'm looking for tan, I guess. Let's see if that autocompletes for me. Yeah, okay. Tan. Tan H actually I think would be good. And then float type X. Let's go back to the example. They didn't use anything else. So does that build? Okay, well, at least it builds. We're gonna find out if it actually runs. So let's go, let's put our listeners before we forget. Tree state.add parameter listener. For input on this, and then another one for output. And then this is going to be tree state.remove parameter listener. That's going to be input and output. This, do another one for output. Very cool. And I guess let's do our update parameter. Update parameters, and right here, update parameters. Let's see, is it going to do it for me? What? Void update parameters. There we go. Xcode is just being slow. So let's call update parameters in here. And then what we're actually going to do in update parameter is set gain decibels with the input and output. Let's see, input. So this will drive the input into the tan shaper harder, which will give us distortion. And then the output module will allow us to trim without affecting how much distortion there actually is. And then we'll basically do the same thing except with output. Good. Okay, so we've got that. We're gonna call update parameters in prepare to play just like last time. But we also need our spec. Here's spec. Okay, we got us a spec, very nice. So input module.prepare, and we can't forget to also do input module.set ramp 20 milliseconds so that it's nice and smooth. Prepare the output module as well. Duration in seconds. Cool, and then we need to just prepare the distortion module and see if it actually distorts. Okay, so we've got update parameters happening. We've got our prepare. This looks like it's correct. Update parameters. We've got listeners, and we just need to process the 3 modules. So here we go. All right, we're gonna make another audio block. DSP audio block float. We'll call it block, and we will pass in the buffer as the data to point to. Now we just call process on each module, and we've got us a plugin. Context replacing, yep. Pass in the block, and that's it. So distortion and output, and let's get our save state stuff. So here's save, which goes in set state, and here is recall, which goes in set state. Okay, that looks pretty good. All right, let's see what happens. We're gonna have to test it. I want to test it in Plugin Doctor first, just in case something weird happens. I don't want to blow our ears out. Okay, that'll take a minute, I guess. All right. So we're gonna have to do the same thing to test in Plugin Doctor. What I'm gonna do is go into here, get the build. Here's the build, put it in the other library, and then I'll open it with Plugin Doctor. Get rid of that. And okay, I already forgot what it's called. Wave Shaper Basic. Okay. Okay, it's in there, and I think it's working because we've got a little bit of a volume dip. Usually get that with distortion. So let's pull up the oscilloscope. Yeah, it's starting to look distorted. Yep, look at that. We got some distortion. Let's see. Kind of hard to see it all the way. So let's just pull the output down here. Look at that. Oh, that's an interesting shape. Yeah. That's cool. And it looks like it just barely clips, like it goes above 1. So what we could do we could add a limiter. That would probably be best. Let's add a simple limiter. Now, let's see. Limiter module, come on. Prepare. And if I remember right, we don't need to set anything on the limiter. Or I guess we need to set the threshold and release. Yeah. We're not going to change that, so we can put it here in prepare to play. So let's do limiter dot set threshold in dB, so 0. Or we could do 0.99, whatever. And then let's also do limiter dot set release, which would be, I'm not even sure. Let's do 1, which I think is milliseconds. Yeah, milliseconds. Okay. And we just have to call prepare after the processing. So let's do it in between distortion and output so that the output brings down what is limited, but it still limits the distortion. So that's not spelled correctly. Limiter. So the limiter should be limiting the distortion. right, let's see here. Yep, I think. Oh wait. Actually, I don't know. It seems like it's still going over. Let's see. Okay, there we go. It seems like it's okay, we've got it's at 0 and 0. Let's go back to linear analysis. Okay, so it's 0. It's still at 0. And output, okay. Okay, I think we're okay. Okay, I think we're alright. Let's open it up in Logic and see what it sounds like. All right, let me pause the music here. Is this still good? All right. Certainly sounds like distortion. And if we pull the output all the way down, it still sounds distorted. It's just quieter. And there we go. A distortion plugin. Look at that. That was pretty simple. Very good. All right. I think everything is good. So let's go ahead and commit that. Wave shaper basic example. Done. All right. Kind of a weird time. I don't think I can really finish anything else. But I think when I come back Tuesday, we'll go to the compressor and we will make the advanced version with a GUI, make it look kind of nice, and then we can add some extra features like auto makeup gain, which would be nice. And yeah, thanks for watching. I will be back Tuesday. Join the Discord if you're not in there. It's in the Twitch bio. Check it out. All right, thanks. See ya.